Good morning, students. Welcome to Young Cubs. Today, I have got for you another very interesting topic called Making Y as the Subject. Before starting, let's just jot down the rules for making Y as the subject. So, the rules say leave Y alone. So, eventually, you have to bring all the variables, all the coefficients, all the numbers to another different side and leave Y alone. And then finally, when everything is sorted, you bring Y to the left hand side, and that's when it is known as making Y the subject. Let's look at these sums. Here we go. So the first sum says x is equal to 3 plus y. So first rule, let's leave y alone. That means I will bring 3 on the other side. Let me use another color. I will bring 3 on the other side. So when sides change, the positive becomes negative. So this becomes x minus 3, which is equal to y. So y has been left alone, and then we need to bring y on the left hand side, which means y is equal to x minus 3. Understood, children? Let's look at another one to get some clarity. There is a misprint out here, children. Let's see what the second sum says. A plus 9c minus y is equal to 14. We have to leave y alone, as in we have to leave y in a positive format. Here we have y, remember, in a negative. It's a negative y. Alright, one by one, let me, deport all the others. So we say first I'll take this A on the other side. So a positive A becomes a negative A. So 9C minus Y is equal to 14 minus A. Let's bring 9C, a positive 9C on the other side, and we are left with minus Y is equal to 14 minus A minus 9C. What about this minus sign now? So this minus sign means it's a minus 1y. So between a number and a variable, okay, there's always a hidden multiplication sign. So when we move the minus 1 from the left hand side to the right hand side, the multiplication sign changes to a division sign. So y is equal to 14 minus a minus 9c upon minus 1. Isn't it similar, or can we not put the minus sign to the entire fraction like that, or to the entire thing? Okay, and now this looks like minus 14 plus A plus 9C. Let me rearrange this again. So this is y is equal to A plus 9C minus 14. Here y has again become the subject. Children, this form over here is also good. I have just done this for my convenience, or maybe I feel it looks better that way. Let's move on to the next sum. It says half 1 and 9a, which becomes 9a upon 2 plus 3y is equal to 27. I shift this entire fraction to the RHS, which is 3y is equal to 27 minus 9a upon 2. Whenever there is a whole number and a fraction, okay, it's when you're adding or subtracting a whole number and a fraction, the denominator of the fraction gets multiplied by the numerator, which is 54 minus 9a, and the whole numerator gets a common denominator. Alright, so here now I leave y over here. 54 minus 9a upon 2 into 3. I haven't multiplied this as yet, children, so for some obvious reasons you will find out. Now, should I factorize this numerator? The common factor out here is 9. 6 are 54 and a upon 2 into 3. 3 ones are 3, 3 threes are 9. Alright, so y is equal to, you can either write it as write it as 3 into 6, 18 minus 3a upon 2, or you can leave it that way, 3, 6 minus a upon 2. Anything is good. So both your answers out here are correct. 2y plus 5 is equal to x. Let's start shifting. 2y is equal to x minus 5. Y is equal to x minus 5. Since there is a hidden multiplication sign over here, when it moves to the other side, it goes in the denominator, symbolizing division. X is equal to y upon 2 minus 5. So this time the y is on the right hand side. First we will leave y alone and then bring it to the left hand side. So it goes as x plus 5, as I'll bring the minus 5 on this side, and I'm left with y upon 2. Then, since it's in the denominator symbolizing division, when it moves from the left hand side to the right hand side, the 2 will multiply with the whole. So 2x plus 10 is equal to y. Let's bring y on the left hand side. That's how y becomes the subject. So this topic, making y as the subject, can be complicated, can be easy, provided you do it you sort one monomial each time. Don't go about doing the whole thing together. Don't use shortcuts. So here in this one, x minus 5 is equal to 2y. Break down this. X minus 5 upon 2 is equal to y. Making y as the subject, bringing it to the left hand side. X minus 5 upon 2. Let's move on to the next one. Okay. It says, let's do it stepwise. A is equal to 2 into y. You can do it 2 into y and 2 into 5 like that, or simply we could also go about breaking the bond out here. There is always a hidden multiplication over here as well. If you can straight away bring it down as a upon 2 is equal to y plus 5. A upon 2, if the plus 5 moves on If the plus 5 moves on to the left hand side, becomes minus 5 is equal to y. Bring the y to the left hand side, a upon 2 minus 5. That's your answer. R is equal to y minus 5. R plus 5 is equal to y. Y is equal to r plus 5. This was really simple. X is equal to 4y. So here we have to break the bond. There's a hidden multiplication on the right hand side. When we bring the 4 on the left hand side, it will become division is equal to y. So y is equal to x upon 4. Here we are. D is equal to r plus y. So d minus r is equal to y. Y is equal to d minus r, and here. Quite simple. I hope you are getting a hang of how to make y as the subject by now. There are a little more complicated ones. I will be doing that as well. So here we go. This denominator moving to the left hand side will get multiplied to z. So it becomes 2z is equal to y plus 2. This plus 2 moves on. This plus 2 shifts to the left hand side now. So it becomes 2z minus 2 is equal to y. Y is equal to 2z minus 2. And that's your answer. Y minus 4 upon 7 is equal to r. Very simple. Y is minus 4 upon 7 entirely goes to the RHS. Y is equal to r plus 4 upon 7. That's your answer. Sums are getting simpler now. So there is a hidden multiplication sign over here. So when the 2 moves on to the LHS, it becomes division. Y plus 5 q upon 2. When 5 shifts on to the LHS, becomes minus 5 is equal to y. Bring y to the LHS. Q upon 2 minus 5. Children, if you leave your sum over here at this stage, the teacher will definitely mark this wrong. It is important to come to the last stage where y has to be brought to the left hand side. Z is equal to y minus 5 upon 2. So this 2 shifts to the RHS, becomes 2z is equal to y minus 5. Minus 5 comes to the other side, becomes plus 5. Y is equal to 2z plus 5. Alright. R is equal to 3y minus 1. So R plus 1, the 1 shifts with the sign, is equal to 3y. Separating 3 from y. Division, symbolizing division, going in the denominator. Y. Y is equal to R plus 1 upon 3. Good going till now, children? Here we go. A is equal to yx plus 8. So first let's shift plus 8 to the LHS. So A minus 8 is equal to yx. breaking the bond between y and x, the multiplication bond, x will become division, come in the denominator. Y is equal to a minus 8 upon x. Alright, over here you cannot simply do the shifting. First, one by one we will shift each monomial. So z on the other hand, so 3 plus 4y is equal to x upon z. Eventually shift 3 on the other side, so 4y is equal to x upon z minus 3. Now do what? Before I shift 4 on the other side in the denominator, I will have to have a common denominator over here between the two. So 4y is equal to, remember I just told you that if a whole number and a fraction number are added or subtracted, they need to have a common denominator. So for which the denominator will have to be multiplied by the whole number. So x minus 3z, and then they get a common denominator as z. Now you can transfer the 4 in the denominator, and this becomes 4z. Moving to the next. Shift the 3 to the LHS. So 3x is equal to y plus 9. 3x, the plus 9 will become minus 9 is equal to y. Y is equal to 3x minus 9. Do not forget to highlight your answer by making a box around it, children. So v is equal to x square y. It's very simple. Multiplication bond goes to the left hand side, goes in the denominator, and we make y stand alone. Y is equal to v upon x square. Two very simple rules, children. Go make y alone, stepwise, separating each monomial from it, and then once it's done, bring y to the left hand side. Okay, so again here, this one goes and multiplies with t, so it's kt is equal to 3y plus a shifts, so kt minus a, sign changes from the RHS to LHS, separating the 3 and y, kt minus a upon 3 is equal to y is equal to kt minus a upon 3, and here we have y as the subject. Here we have h is equal to 4ay minus 5g. So let's take 5g on the other side. So minus 5g becomes plus 5g is equal to 4ay. Separating 4 and a from y, hence it will go in the denominator. All have a multiplication over here. If you see, it's 4 into a into y. So I can always separate the y from both of these together, bringing them in the denominator. Y is equal to h plus 5g upon 4a. And here we go. It says a is equal to half xy. So first, let me write it again for a better understanding. So these two get multiplied by 1. So I can now write it as xy upon 2. Shift the 2 next to a, becomes 2a is equal to xy. Break the x and y bond. X comes in the denominator. Y stands alone. Y is equal to 2a upon x. S is equal to 3xy minus 2h. Take the minus 2h on the left hand side. So S plus 2h is equal to 3xy. Break the bond out here. 3x both can leave y alone and come to the denominator, simply because multiplication, when changes sides, becomes division. Y is equal to S plus 2h upon 3x. Here we go. Quite simple till now, children. T is equal to pi y minus p upon q. Because of the pi sign, you may get worried. Do not do that. TQ is equal to pi y minus p. Q moves on here. Now P will shift to the LHS, so with a positive sign. Simple till here. Bond of multiplication breaks here. TQ plus P. Bond of multiplication breaks on the right hand side and becomes a division on the left hand side. And here I have my y alone. My first rule fulfilled. I've brought the y on the LHS. My second rule fulfilled. And here it is. No rocket science, children. V is equal to 1 upon 3. 1 upon 3 pi yq. Again, let me rewrite it for simplicity. Y is equal to 1 upon 3 pi yq. Oops. yq. This whole thing gets multiplied. V is equal to pi yq upon 3. 3 shifts to the LHS. 3v is equal to pi yq. I can separate the pi and the q together. Since there is a multiplication sign on the LHS, it reverses and becomes the division sign. Going in the denominator, y left alone. Brought y to the LHS. And here, this is your answer. I hope, children, you are getting a hang of this topic. X is equal to y upon 5 minus a. Shift the minus a to the LHS with the sign. So the sign changes to plus a. Y upon 5. Now this 5 in the denominator multiplies by the whole polynomial or binomial. Okay, so 5x plus a is equal to y. This becomes 5x plus 5a is equal to y. You can either, alright. Then y to be brought in the left hand side. Y is equal to 5x plus 5a. Either this is also correct, and if you do not want to factorize, or rather you want to keep it in the factorized form, this is also correct. both the answers are correct. Moving to the next one. Take the 3 to the LHS, so it becomes 3r is equal to y plus 7. Take the 7 to the LHS, so plus 7 becomes minus 7. Y brought to the LHS, and that's your answer. This is a 2-mark question. Let's look at this one now. So let me just simply write it like that. Let's shift the minus a to the other side. Becomes plus a, 5 upon y. Okay, now little different. This y moves here, so y multiplied or y bracket x plus a is equal to 5. Now we have to break this bond again, where we leave y on the left hand side and we transfer the entire bracket in the denominator, because there is a hidden multiplication sign over here. When we separate the two, it becomes division, and that's your answer then. Do not try solving this here, because you will get 2 y's, and then it will become difficult for you to bring it back to 1 y as the subject. Last sum, 3q. Let's shift the 5b plus 5b is equal to 2y. Break the multiplication out here. 3q plus 5b upon 2 is equal to y. Y is equal to 3q plus 5b upon 2. Hope this topic was easy for you guys, children. Thank you so much, and God bless all.